This is worksheet 14.7, and we're going to first look at the questions from 5 through 8. So in this problem we have a certain type of radioactive goo, and its decay in grams can be measured by this equation, where n is the number of weeks the goo has been monitored. What is the percentage of goo that is decaying each week? So this equation that's given is representing the amount of goo that's present at a given time. So if the initial value in grams was 1600 and we're multiplying by 75%, that means the decay is by 25% because there's only 75% of it left. So 25% is decaying, which means 75% is what's left. In number 6, how much goo was present 3 weeks ago? This is a key word here because this is referring to the past. The current was 1600. If we're trying to figure out the amount that was present 3 weeks in the past, then our exponent for n is actually going to be -3 since it was 3 weeks in the past. So in your calculator, let's calculate, so 0.75 to the -3rd. And then that answer gets multiplied by 1600. So we can see here that the amount left is 3,792.6 grams. Right, in number 7, write an algebraic expression that represents the amount of goo present 10 weeks ago. So the expression, we're not actually calculating it, but if we wrote an expression, we would have 1600 times 0.75, and then 10 weeks ago means 10 weeks in the past, so -10 would be the n. The last question here is, how long will it take for there to be less than 10 grams of goo remaining? So we know the result should be 10, and we're trying to find how long that's going to take. So as of now, so far this year, we haven't talked about how to solve an equation like this that has a variable in the exponent. So what you can do is just guess and check and see what n would have to be equal to make this work. So take a guess. For example, if you think it's going to take 10 weeks, you would type that in and test it out. 0.75 to the 10th, and then multiplied by 1600. We still have 90 grams of goo left, so we can keep increasing our n value. Now I'm going to try n equals 15 times 1600. There we have 21 grams, so I need an even higher value of n. I'm going to try 17, so 0.75 to the 17th times 1600, still have 10. So we still have 12. So we need less than 10 grams. I'm going to increase it by one more, so let's try to the 18th, and then times 1600. And there we have less than 10. So this is an approximation because of the way we're guessing and checking. So I'm going to say that n is approximately equal to 18 weeks. And that's it.